Double angle identities, part 3. A summary of the identities that we've already seen in part 1 and part 2. Example 3, so we're starting off with an equation and we can see that there is a double angle relationship. So we have theta, and double that angle gives us 2 theta. Now the question is, work out the exact values of sine theta and cos theta. So we need to get rid of this double angle. So we'll use the double angle identity for sine 2a, which is 2 sine a cos a. So if we write this identity, but in terms of the values given here, we're using angle theta instead of a. So we've got sine 2 theta is equal to 2 sine theta cos theta. So now we can replace the sine 2 theta with 2 sine theta cos theta, and that gives, so that 2 there is this 2 here, and I've replaced sine 2 theta with 2 sine theta cos theta. Now what you wouldn't do next is think about, well, why don't I just divide by sine theta on each side? If you do that, you get an equation only with cos theta in. You end up with this. Cos theta is equal to, and that 2 times 2 there is a 4, so that's a 4 cos theta. If I divide by 4, I get 1 over 4. Cos theta equals a quarter. I don't get the sine ratio. I have a cosine ratio, it's a quarter. I've got this part, but not this, not for sine theta. So that was a bad move. Okay, so instead I've taken all my terms to the left hand side. I've moved the sine theta term to the left hand side of the equation. I've just simplified here. 2 times 2 is 4, there it is. And now you can see there is a sine theta term here and here. So let's start with some factorization. Let me put the sine theta on the outside. So inside I've got a 4 cos theta minus, and sine theta times minus 1 will give me that minus sine theta term equals 0. So for the equation to be equal to 0, either this factor is 0, so either this is true, or this factor is 0. So cos theta is equal to a quarter, and that answers the original question. The question did not say solve to work out values of theta. Yeah, you could easily do sine inverse of 0, get some angles, cos inverse of a quarter, get some angles. They would probably give you a specified range, like theta is between 0 to 360, that kind of thing. But the question didn't specify that. All they said was work out the values of sine theta and cos theta. So the sine ratio and the cosine ratio. Now one of the key things behind the solution is to get all the angles the same throughout. So at the beginning we had 2 theta and we've got angle theta, so they're different. And the aim here was to use some identities and to rewrite the original equation there, but with the same angle throughout. And right here we have that, we've got angle theta, theta and theta, the same angle throughout. Example 4, right, cos 3a in terms of cos a. Right, so that's not a double angle relationship. If you've got angle A, if you double that you get 2a, you don't get 3a. So we need an intermediate step first, where we split the 3a into angle 2a plus a, like this. Okay, so all I've done there, I've taken my cos 3a term there and I've split it up into cos 2a plus a. And now we can use the addition angle formulae, not double angle but addition angle formulae. And you'll recall from previous videos that there was an identity for cos a plus b. So it's like the a is 2a here and b is a, And using that identity, we can write cos 2a plus a like this. Okay, that's the identity that we're using. So I have a double angle relationship now. That wasn't there at the beginning. Remember, at the beginning we had angle A and 3a. This is triple this angle. But now I have angle A, and we have angle 2a. So we do have that double angle relationship now. And we know how to deal with cos 2a, we know how to deal with sine 2a. Now cos 2a had a number of options, these, but if we want to stick to a solution with just cosine, this is the one that we want to aim for. All of the others work too, but the solutions are longer. The most direct and most efficient solution will be to use this identity, to stick to cosine rather than having a mixture of cos and sine. Okay, so cos 2a is 2 cos squared a minus 1. So I've changed from the double angle, changed from 2a to angle A. And sine 2a is 2 sine a cos a, and again we've gone from a double angle 2a to angle A. Now we simplify. So on the left hand side, if you multiply these two together, you get a cos cubed term. That will just give you a cosine term. On the right hand side there's a sine a, it multiplies with another sine a, so you've got sine squared a, and that cos a is here, and we have angle A throughout. It's the same angle throughout, and we were trying to write everything in terms of cos a, so that's a good term. It's in terms of cos a, so is this, but that's causing a problem. That one's okay, but we know sine squared a is 1 minus cos squared a, so sine squared a is 1 minus cos squared a. That 2 cos a is here, 2 cos a, so again we have to multiply out the brackets. Be careful with the signs, there's a minus 2 cos a which is multiplying with everything in the brackets there, so we expand and we get these terms, and then simplifying, so collecting like terms, there's a cos cubed term here and here, and these are both cos a terms. So here's our final answer. So we've worked out cos 3a in terms of cos a. This is a cos a term as well. It's just cubed, but it's still a cos a term.